Today's video is on graphing absolute value functions as well as absolute value inequalities. The absolute value function is written as y equals the absolute value of x. That's the standard, what's called parent function of the absolute value. In the table, we have all the inputs, and we're going to input them into the absolute value x and see what our outputs turn out to be. Putting in -3, we get 3. Basically, it's all the positive values. Now, graphing all these ordered pairs, starting at the origin, it's going to look like this. And then we would connect our dots since it's an equation with arrows at the end. Talking about our domain and range now, the domain is all real numbers. You could write from -infinity to +infinity. In the range, the lowest to the highest, you could say it goes from bracket 0 to infinity. Or if you wanted set notation, you would say y such that everything is greater than or equal to 0. So the graph does look like a little V, an upwards V. The turning point right here, that turning point is called the vertex. Let's talk more about graphing different types of absolute value functions. Number 1 here, it says the f of x equals the absolute value of x minus 4. The first step when graphing using a table is we're going to take what's inside the absolute value and set it equal to 0. Doing that, we'll get x to be +4, and that's the x coordinate of our vertex. We're going to put that in the middle, because the vertex is the middle of the graph. Then going back and substituting in 4 in for x, we get 0. After that, we can keep on putting domain values below 4 and above 4, and figuring out what their outputs would be. Plugging in 1, we would get 3. Plugging in 2 would get 2, 3 to get 1. Plugging in 5 to get 1, 2, and then 3. You sense a little pattern here. Now let's graph it. Start with the vertex over 4, up 0, 1, 2, 3, 4. And then you can graph the rest. I'm going to do the best I can without a ruler to make these straight lines. And don't forget arrows at the end. The domain of this graph is all real numbers. The range, the lowest to the highest, goes from, again, 0 to infinity. You would do the same thing in number 2, setting what's inside the absolute value equal to 0, finding the vertex. Again, sometimes the vertex could be a fraction, so you'll have to deal with that. And then you would go lower and higher to find your other coordinates on this graph. If you were trying number 5, setting x plus 1 equal to 0, you'd get the first vertex to be at -1. Substituting back in -1, you would get -1 plus 1, which makes 0, and then take the negative, still 0. Figuring out to make other points like this, 0, 1, and 2. If you kept on doing this, you would actually let me do this so you can see what the graph looks like. I just filled out the table by substituting in numbers, and I'm going to graph this as well. Start with the vertex, -1, 0, going this way, and then making as straight as a line as possible. That is not going to work. Let me try that. Notice how the function goes downward. That is because of the negative in front. If you see a negative in front of these absolute value equations, it is going to point downward like a reflected V. The domain, again, is all real numbers. This time the range starts at -infinity and then ends at 0. It's not always going to end at 0 or start at 0. If you try number 4, it would be a different range. It's just the examples that we've done so far. Numbers 7 and 8 are both piecewise functions. I'm not going to do this right now. It might take too long. We'll definitely start it in class, so we will skip that. Let's move on to graphing absolute value inequality. Let's graph these inequalities the same way by taking what's inside the absolute value and setting it equal to 0 to find our vertex point. So the graph starts at -1. Let's put that in the middle. Substituting in -1, and for x, we get -1 plus 1 is 0. Then let's plug in other points as well, just like the other part of the notes. -2 plugged in gives us 1, follows this pattern, and it's symmetrical the other way. Graphing it looks like this. Okay, now comes the different part. It's not always going to be a solid line. It might be dotted. Here's how to check. Read above. If you do not have an equal to sign on your symbol, then it's going to be dotted. So you just leave it as a dotted line. If it had an equal to sign on the symbol, then it would be solid, because we're not including these points in our solution set. It's everything less than those values. Next step we have to do is shade. You're either going to shade above the graph or below the graph. If it's a less than symbol, like this is, you're going to shade below. If it's a greater than symbol, you're going to shade above. So take a colored pencil or use your pen or your normal pencil and shade everything below. Do the best you can to be as accurate as you can below this graph. And all of these ordered pairs that are below this graph are your answers. There's not just one answer to the graph. There's an infinite amount. So take any point, we could say this one right here. If you substituted it in for x and y, it would make a true statement. It would say blank is less than blank, which is true. All the other ordered pairs that are not shaded, including the dotted lines, these ordered pairs on the dotted lines, they're not solutions. They don't make this statement true. Let's do another example, a little more difficult. Let's do number 4. Let's set that equal to 0. So we get x to be 0 here. And then substituting that in gives us -0 plus 3. That is just 3. And we can go below and above. Let's finish out this table. I'll pause the video and finish out the table and the graph. You see that the table does make a little symmetrical pattern around the vertex. Let's graph now. 0, 3, -1, 1, -2, -1, symmetrical on the other side, just like that. Okay. Next thing to check is it's solid or dotted. There is an equal to sign. That means we do have a solid line going in both directions. Next thing to check is it shaded above or below. It's a less than sign, so we're shading below the graph, which is everything here. Therefore, your solutions are everything in green, as well as my solid blue line. Those make this inequality statement true. Write down what questions you have on today's video on inequalities and equations and graphing them, and have a great night.